Let's see. Hello. All right, good. The sound is working for the recording. Because I ran into this issue the first recording. I did it, and then I realized after the session that it did not have any voice on it. It just wasn't fun. I had to re-record it. All right, so happy Saturday to everybody. It's MLK Day on Monday. No, I still cannot hear you on my end, but I can hear Cyril, I can hear Andy. Emmanuel, I cannot hear, but Emmanuel, I expect to join the conference bridge. Emmanuel, are you on the bridge?
Yeah, I can hear you.
Okay, good. So Emmanuel is on the conference bridge. So we'll start. Now just try to see if you can maybe a microphone issue on your end. Yes, I can hear you. So try to speak up if you want to say something during the session. All right, so the schedule, the outline for today is obviously, I want to go over the homework, then review a bit of the session we did. Then we'll do more of a query workshop, then talk about the Oracle database server architecture, right? That's the general outline for today. Just want to revisit what we had discussed during the last session, and then we'll go over the homework. So the last session, we did introduce, try to discuss, or at least get into detail about, certain advanced topics in terms of table structure as a database object. And we discussed partitioning, and along there we mentioned storage and chaining concerns. That was like the only new thing that was introduced last session, which was Wednesday. I know, Cyril, you missed it, and I don't know if you got a chance to watch the video.
Yeah, I watched it. I had a rough idea of what was discussed, partitioning and indexing, stuff like that.
Right, and so we left off.
New words.
Yeah, exactly. Yeah, and we left off the session with Andy asking a very, very important question about the difference between partitioning and indexing. So we would touch on those topics during the review. Once we've done the review, any concept that you need more clarification on, obviously we can do some more analysis if needed. Now, so I got one homework assignment, right, from Cyril, and I'm not entirely sure if it was a group effort again, or just purely from Cyril. So I presume since it came from Cyril, it's just for Cyril. So Emmanuel, can you confess what happened here?
I'm sending mine right now.
All right, please send it. Please send it. Okay. So then it wasn't a group effort. And Andy, I didn't get anything from you. All right. Like they do at my son's Taekwondo class. If you start doing it, I'm gonna start giving you points.
So,
okay. All right.
Andy, please send your work.
No sharing on this one. No sharing. All right. So
when was the last time we spoke, Andy?
All right. So regarding the assignments, right? So please send them over, and I'll quickly just restate what the problem was. So I gave the assignment mainly to try to confirm, or at least help you guys to get more practice with some of the analytical functions that we've been sort of playing with in terms of using inner queries to try to get a result set that you can use to do some other computation down the line, right? We did review it extensively during the last session, and I did make an observation that folks needed more practice in order to get comfortable, because for a SQL interview or for any job interview in this area, you are going to get cases where they may actually ask you to take a test online, right? Where they'll give you, you guys have been through it, where they may give you an assignment, they will put the query together online, right? I am available if such a scenario happens, and let's say you're doing the test online and you need to do team viewer for us to go through it. We can do that. However, if that's not the case and you go to a job interview itself and it's down to 2 candidates and some manager says, hey, let's give them some SQL and figure out whoever solves it gets the job, then it won't work to your favor. And I've seen that happen, where sometimes they will just, we come choose between 2 candidates and we just, okay, let's throw this SQL at them and see who has a few ideas. And the one who has the best idea gets the job, right? So I want us to really get a lot of hands-on practice with this stuff. So I'm still waiting for your emails to come through regarding the, let's see. So I don't have, okay, I got Emmanuel, let's download Emmanuel's. And Andy is in the mail, I guess, right?
No, I just dropped mine
in the invite. Okay, in the file, sure. I'll grab that too. So go to the file box and let's download this file onto my desktop here.
The big man dropped his file.
Yeah. So now, just so that there are no feedback issues or whatever it is, if at any point people are having a problem hearing me or they are having a problem, I may have to turn down your microphones, right? Turn it off on my end, just so that folks can hear. But so far, I don't think anybody's having an issue in terms of hearing, correct?
No, not for me.
You're all good. All right.
No.
Cool. So, Cyril, yours is the one that is actually on board right now. I'm going to share my screen. And where is the SQL developer? There we go. All right, let's go to the recording session and change the screen share to SQL developer. All right, so both are in sync. All right, so Cyril, you sent this one to me, and what I was trying to figure out was that in response to the assignment that I gave to you guys, the first one, or was this the second one? All right, so quick thing I want, that, maybe a quick test is you're submitting your assignment, right? And you say line number 1, you say question -1, right? Comment, it's not a query. You really want to put dashes in front of them, right? Or you do the multi-comment line. So if you have a lot of comments that you want to, yeah.
This one.
Yes.
For some reason, I can't show cache. I wasn't see it, but now it's okay. I'm good.
All right. So, if you need to comment out multiple lines, then you do this, /* and then with a closing that, right? But if you have just one line, then it's best to just use dashes, okay? Either way can work. I mean, if I have a lot of lines, I'll just use the /*. But if I just have one line, then I'll use that.
I can't see your screen though. I still see this screen viewer. I mean, I don't. My screen is blank. I don't.
Your screen is blank. You can see the team viewer, the SQL developer.
Yeah.
Is it better for everybody? Everybody can see the screen?
Yeah, I'm good now.
Okay. So let's do this. What I'm just showing is that in your assignment submission, right? You had question 1, right? And just to show some professionalism, you really want to put dashes to show that it's a comment, right? I'm not trying to nitpick actually. So anywhere that you have, like this section, for example, where you want to put these things, you can put that. You put the 2 dashes, and that would tell the interpreter that this is actually a comment, okay? So And what I was highlighting before was that if you have multiple lines, then you want to do this. You want to do something like that. I'd say, I have a question and I'm going to solve it. Right? This is to come if you have a in your notes when you're writing queries. It's actually very helpful to put commentary in your notes so that when you come back to it, you can remember why you did it the way you did it that way, right? So it's actually a very good practice to always put commentary in your submissions, right? Whether it's production code or even test code, you should always put commentary in them. So that goes for everybody, not just for Cyril, because I think it's not just him. All right, let me see Cyril's assignment. So let's see. So so this will be. Did you say, Cyril, this is for what session? The last one or the previous sessions?
Yeah. No, the last one that you sent me.
Okay, so section 3. Okay. Okay, so what was the problem statement, right? I keep harping on that. What exactly, you have to make sure you really understand what the problem is. So who remembers what the question was? That was the first question. Okay.
It's said find how each department's salary is relative to the entire firm.
Good. So basically, we need to figure out which department, how much each department is making, and then compare that to the salary of the entire firm. Okay. So I have yours. Let me open up manuals. And where did I save you? I think I saved yours on the desktop. Then the manual is in the downloads, I think. Okay. So there are two questions, right? The first one is for each department, tell me how much money they are making in that department relative to the entire firm. And the second part of it was sort of a twofold, right? Which was for each employee, find the ratio of their salary to the average salary in their department, as well as the average salary of the entire firm, right? So if you work in any company, you work in a department, you want to make sure that you're being paid at least above the average, right? Not below the average in the department. So that's a very good, important metric to keep track of. And then, you may also want to find out how you're doing relative to the entire firm, right? To get a good guide. But beside the potential benefit for, from our paycheck standpoint, it's actually a very useful analytical tool, right? Because oftentimes you do a lot of comparisons in a lot of analytical projects you work on, you do a lot of such comparisons because it gives you a guide as to how you make a decision. Okay, so do you increase somebody's salary if it falls below X% of the average salary in the department, for example, right? So your manager can give you an assignment. Go tell me how many employees are currently earning below the salary of their department, or on the other side, hey, who's making so much money in their department, right? And what exactly warrants that they make so much, okay? So that's effectively what the assignment was. Now, I'm going to start with Cyril. And to be quite honest, I think, Cyril, you combine a couple of things. So I was looking at it and I wasn't so sure where you're going with it. So I'm not sure which one. Let's see. So the first part of it, I think you're looking at last week what we did. So I really couldn't tell. The only one that I think seemed to. So okay, let's run this one question. The second one seemed to be the one that had, yeah. So this one is sort of is there, but it's not there because there's a lot of repetition, right? So if you look at this, right, the first thing you have to ask yourself is, how many rows should you expect in your output? Emmanuel, how many rows should we expect? Well, the first question as to, for each department, how much salary is that department making relative to the entire firm? So in the final result, how many rows do you expect to come back?
Well, there's 12 departments, so how much?
Yeah, so that's good. Effectively, that should guide or tell you, whether your answer makes sense or not, right? Because if there are 12 departments, then effectively I just need to show all the 12 departments their salary and the salary relative to the entire firm. So because you actually have the right idea, but I'm going to use your example here to simply show you one feature in Oracle, like distinct, right? If you have a result set where there are such duplicates, one, it tells you that the query is wrong, but if you've tried and you have no idea how to remove the duplicates, just use distinct. So if you use distinct, then it would, in your result set, at least filter it down to just the, departments and whatever, right? So I'm not saying it's correct. It's actually not correct how you solved it, but if you use distinct, you can get, I'll give you like 80%, right? But I hope you guys realize that, well, at least understand what I'm saying in terms of his output, which is he's repeating the department IDs and the salary and the total salary in that department and the salary by firm. And you basically can use distinct to then just filter it out to just say, for every department, give me the, so again, that's not the approach you want to use. However, it gives us an opportunity to learn how, or a scenario that you can use distinct, okay, to apply to a final result set. This approach is dangerous because imagine you're dealing with 10 million records. Distinct can take a very long time to come back because the database has to compare all the records and figure out which ones are the distinct records, right? And that's a very expensive process to do if you're dealing with 10 million records or 100 million records. So that's why I'm saying that it's not a good approach to solve the problem this way. Okay, so that's that part. And then the question 3, you said, okay, let's run this. Not sure. Okay, so here, okay, all right. So I hope now that we've restated the problem, at least you understand why the solution here is a bit is off, right? Because we really wanted to see for each employee how much they were making relative to the average salary in their department that they exist in, and then secondly compare their salary to the average salary within the entire firm. So again, if somebody's making $10,000 a month, for example, and the average salary within the department is $5,000 a month, they are making twice the average salary in the department. And maybe the average salary within the firm is $8,000, right? So in that case, they are making 25% more compared to the average salary within the firm, right? So there again, your result set should be, we wanted to see for every employee, right? So 6 or 7 or 8 records, depending on the number of employees you have in your version of the table. So that should also guide how your response should be. So since I don't see any employee ID in your output, I know it's off, okay? So that's the feedback there. Let's start for Andy. Let's see. So, all right. So Andy, try to save your files as .sql files. Okay. All right. And Not a new database file. Open it up. Browse. SQL. This is homework. Submissions. And the okay. So I'm gonna just save yours here. All right. So Andy, do you want to walk us through your solution here?
Yeah, I can do that. So I'm looking at this. I'll start from the middle part here, where I need. Actually, this will be for the final part of the question. I think I didn't submit the first two questions.
Okay.
The first two questions.
Okay.
So in the middle, this select here is I try to calculate the average salary for the department. No, that's the salary for each employee relative or as a ratio of the whole firm's total, right?
Right.
Or the average of the firm's salary. So here I did my calculation is here. Am I showing you the arrow of where I'm pointing at?
Your key.
Okay. Yeah. So my calculation is here as an employee salary to the firm's average.
Okay.
And then I did the other stuff like group by, order by, and so this is a table that will generate within the query. That's the DT as you do it.
Right.
And then for the main query, I just wanted to expose this column. And then within the column, I have this calculation for the department's salary to the comparing the department salary to the firm salary, and then the next column will be the employee's salary compared to the average of the firm salary. So
okay.
Yeah. So I pulled some of the columns from here because I have this calculator field here that I would need in doing my calculation right here.
Right.
Yeah, so I just pulled this column from here from DT and did my DT that column, and then give it an alias.
Okay.
And I should give my yeah. So
okay, that's good. I mean, I don't
hoping it runs good.
Yeah, I don't think it's gonna run.
The final
yeah.
line here, select some, so like it's not part of the. Yes, that will be out of my the answer for the.
I actually wanted to comment on that. That it's pretty good. I see where you're going with it, which is you were trying to prove the formula that you're trying to put together, see if it's working. So you say, okay, what's the total employee salary? What is the average salary for Department 20, for example, right? So then when your output comes out, you can say, all right, well, I just did it for one department. I figured out that department, the average salary. I pulled the people from that department, and I did some computation just to see if it makes sense. Like that's sort of, they'll call it like unit testing of your results, right? So you've done something and then you break it down to small pieces to make sure that, okay, is it working for the small case? And then if it's working for a small case, is it working for the bigger case, right? So that approach makes sense. It makes sense. It's not really a SQL thing, but it's sort of a general problem solving strategy, right? You do some unit tests, and once it's good, you try to scale it up. Okay. So let's I'll put it here. I don't think it's going to run just because I see a couple of typos. So question I want to ask you is your local Oracle database running fine? Do you have any issues with it, or?
It run. I got the results, but those typos, because when I was about to submit, I just thought, oh, let me just clean it up a little bit.
Okay.
And that's when I think I made those. I can correct them. I mean,
no, that's fine. I mean, we're just gonna run it here. If it comes back fine, I just made one correction to this because I think I saw, in one place, salary was without an R, so that's fine. Let's see. So I suppose this top part would answer the main question for really the question two, the last question, right? So again, the problem I have with this approach is if I'm looking for every employee, I want to see the employee ID in your results set, and I don't see it. So you have the general idea correct, which is you would say that, you know, for every department, I need to find the average salary in that department, because I need to use it later to, once I know the average salary in a department, I can then compare an employee in that department, right? Their salary to it. So, all right, that's good. I mean, it's a very decent attempt at it. So you get some brownie points there. All right, let's Andy, can you move your cursor again? I want to make sure that all right, can you try to type something? Okay, good. All right. All right, let's I think I got an email for Nana's assignment too, so let me see. All right, go back to SQL Developer. All right, let me open up Nana's too. So open, it'll be in the downloads. All right, okay. This is for Emmanuel. All right, so Emmanuel, you want to walk us through your approach or solution as well, please? Got 2 minutes.
Yeah. So hello, can you hear me?
Yes, I can.
I'm looking at Andy's query and I see this. Okay, so I started with the inner query where you have so with this one, if you run this thing separately, and I'm trying to select this and run it.
Hold on, let me give you remote control so that you can do what you want to do. Yeah.
Okay, so if you run this query, it's going to give you. So this query is giving you the department salary, the total department salary for each department. And so what
is the third column for?
This is department salary.
The third one. That's the second. You're talking about the third column.
I'm sorry, which one?
Yeah, the third column says department to firm. I'm saying, what is that number? What does that represent?
This one?
Yeah, so row number 1, you have department 20, and then it's followed by 19,000, which is what the total salary in that department. And then next you have 9,500. That 9,500, what does that represent?
The 9,500 is the is the average department average.
Yeah, so I mean, I actually want to highlight the fact that if you don't label your columns or your aliases well, it throws you off down the line.
Yeah.
Right, so I'm looking at department to firm and I'm going, okay, what does that mean? The formula says average salary, so why are you going to call it department to firm, right? So
yeah, okay, so I say it has to be like department average to firm.
All right, give me the mouse for a second, and let me just do that replacement. So let's do, you highlight the thing, and you do Control R, and it allows you to, so let's say department average, okay? For the sake of replace all. All right,
so now I have the department average, and then I have the total salary for that department. So once I got that, then I came up here, and then that's when I did my calculation to get for each department the department salary and the department salary as against the total salary, the relative to the whole firm, and then the average. Yes, and then I was trying to answer the two questions in the same.
Never do that.
Okay.
No, I'm just kidding. I'm just kidding. I think once you get advanced with this stuff, then you can try to do those sort of things. But try to go through the headache of, or at least the process of trying to solve these problems from first principles as much as you can. All right, let me just take the mouse back for a second. And yeah, I think you also made a good attempt at it to try to solve the problem from first principles, which is okay. I know I need to use to get some for every department. You need to get the total salary in that department, and then the average salary in that department, and then compare it to the firm, right? Because you're going to use the average salary later. So your inner query here, right? I'm purposely not highlighting your order by because there's no need to do an order by there at all. Which is, so I'm for that department, I know the total department salary and I know the average salary, right? So because you plan to use this later, it makes sense. But your very first question that you were trying to solve was to say, for the department salary, let me figure out the total, right?
Yeah.
Now, again, if a requirement comes to you, you really have to sit down. Like if I'm grading an interview for SQL, I'm interested in watching how the person is trying to solve the problem, but I'm not trying to overthink it or overdo it, right? The first question was, for every department, how much do they make relative to the firm, or how much salary is, their salary relative to the firm? And that's all you should focus on doing, okay? So I see where you're going with that, and I'm especially being hard on Emmanuel because I expect a lot more from him. So that's because I know he knows a lot, right? So, all right, I made a point that don't use the order by here, and the very reason is that order by is an expense that you should avoid unless you are required to do it. If nobody tells you order your results set by some field or some column, don't do it because it's an expense. The computer or the database has to spend time to order the results set. So if you're concerned about performance, you go to a company, they can give you a query and say, oh, why is this thing so slow? I have earned a lot of brownie points in my life as a SQL developer by being able to analyze queries and just get rid of things like this and see a query that takes 10 minutes start running in 1 minute, just because the person is doing a lot of work which is not necessary, right? Because you just care about for every department how much salary they are making, the total salary and the average, there's no need to order it by because you plan to use this result set later, right? So there's no need to even try to use that. Okay. Okay.
Thank you. Yeah, this one I have a question.
Sure.
Do we have any tools in Oracle where we could monitor the performance of two SQL statements?
In fact, you don't even need that. There are multiple tools out there, but you don't need it because oftentimes, from an execution standpoint, it will tell you how long it took. Like so, right now, like when I ran this query here, right? Let's say 0.002 seconds, right?
Okay. All right. That was what I needed.
And then look at the one with order by takes 0.005 seconds. So you move from, think about it, you move from, let's say, 2 seconds to 5 seconds. I mean, right now I'm talking about microseconds here, but that's actually how this thing scales, right? The more data you have, something that is 2 seconds now is running 5 seconds because you have an order by. Okay, so if you don't need it, don't use it. And typically with inner queries, you hardly need to ever sort them. You hardly need to ever sort them, because when you are going to join an inner query with another table or something, the join takes precedence, right? So really, from a performance standpoint, you don't need this, because you're doing this left join, this is more important. And then once you're done with everything, you can order your results in, right? That way. Okay. So just a performance thing, because I know last time we mentioned about performance in terms of why we partition a table and why sometimes you analyze a query and it's slow and the different factors that can come up. Okay, this is not a session about performance tuning per se, but I'll use every opportunity I get to highlight some of them. Okay. So yeah, Emmanuel, I think you made a pretty good attempt as well, but I am still not happy that so far nobody seems to have the second question, which is I need to know for every employee how much they made relative to the department average as well as to the firm average. All right, so let's look at Nana's approach.
Nana will share us. Nana is going to share us.
This is the wrong one, Nana? Let me see which one is it. This one. Oh, the two. Okay, sorry. Let's open this up. Okay, so Lana, do you want to walk us through your approach here, and I'll give you the control, and you can walk us through how you understood the question and how you try to solve it. You got 2 minutes. Can you speak up a little bit, because it's coming through. Maybe your back. If you can't speak very loudly from your background, it's okay. We will keep. We'll strain to try to hear you. Go for it.
Okay, so first question is find out how much each department salary is relative to the right?
Yes. Yes, we can hear you. Go for it.
So what I did initially was if you look at the inner query, I tried to find the Google select by department. Right, so I did the department ID, and then I found the department, and to answer the first, this query, okay, that says the total salary by department divided by total salary for them. That will give you the multiplied by 100 and find the percentage of that. It will give you the department salary. How I understood it.
Okay.
And then the second part, the three questions. For each employee, find the ratio of the salary to the average salary of the department. So what I did was I found the average salary for each department in the inner query. And then I pulled that here. And I did that calculation of finding each employee's salary with that average salary.
Okay.
Say, find the salary. Okay, so for this one I was a bit confused actually. Say the average of the entire firm. So if you see the query that I've commented out, I edited the calculation of each employee's salary to the average
Okay.
of the whole firm. Then when I run the query, I wasn't sure. When I commented it out, I left it in there to ask my question. But if the second one that I did is wrong, then I'm guessing it'll be this one, the one that I commented out. What I did after that, after commenting this one out, was I found the each employee salary, the total of the entire firm. So for that second part of the question, I wasn't really sure. I didn't know.
Okay. All right. So I think that's all right. So let's just talk through that a second, right? So two things that I'll remark is that when you're solving these problems, you have to think about them in terms of breaking them into separate units, right? So I expected two separate queries as a sort of the final solution. I see the thought process you're going through, and this is good. So let's see. Effectively, what you did was, okay, because the whole thing was asking for, for the department, how much they make relative to the entire. So you say, okay, for that department, this is the total salary, and this is the average in that department. And then you plan to use that later. So in your final output, you could, if you do it on the employee level, right, you can show a whole bunch of them. So that's fine. Let's see what the whole thing comes down to. And I'll answer your question about I'll try to address your confusion. The question specifically said, and that's why I was giving this analogy, that if somebody's making $10,000 a year in a company and they are working in a division, right? You're interested in, okay, what is the average salary in that division? And how much is my salary relative to that person in the same division? Because you care, okay, right, we all work in, let's say, sales, and if the average person in sales makes 10,000, 5,000, I'm pissed. Why am I making such a low amount, right? That was a question about comparing an individual's salary to the average salary for the entire, the average salary within their department. The second part was, okay, people get this income inequality debate, right? Which is, you look at a company and the average salary is like 300,000, and then somebody's making 50,000, right? And it's just because a few people are making so many millions. So when it comes out, oh, the company average salary is this, but you look at what you make relative to the average in the firm, you're like, I'm being, what is this, right? So that was the question, which is, well, you find the employee's salary and you compare it to the average salary across the entire firm. So in fact, the one you commented on line number 10 is what I was looking for, which is you figure out the salary of the employee and you compare it to the average, right? And you could have just actually left both of them in there and we can look at it to numbers, right? So I'll rerun your query, what we get. First, we are looking at this from the perspective of for every employee. So since this output needs to be ordered, right, I'll say order by one. First column ascending, I'll just do that, okay? So that it kind of looks cleaner. Now, Cyril, understand that the difference between this output and yours is that in your output where you're just looking at department and the total and the average, you didn't have to repeat. In this case, because she's showing the employee, right, the employee records, that's why it's going to repeat. And that's why I was saying ideally I needed two separate solutions, right? One which just shows this, let me just build on this one here. And that would basically say for each department that, and basically just, I should do it in the same line here. Just say this is inefficient, but I'll just do it just to highlight a point. Select sum salary from this first piece, let me just format it so that it looks nice. All right. So this first piece here should show for each department the total salary and that salary relative to the entire firm. Now, obviously, to format it, we have quite a few approaches we can do. We can do round of this. All right. So department salary relative to firm. And if you want to do the 100% thing, we can just multiply by 100. So, okay. So this is basically 7%, 4%, whatever it is. And this is sort of what I expected for the first problem, the solution to it, right? It's not, again, it's not the most efficient way to solve the problem, but based on what you guys know now, this is at the minimum based on what has been communicated so far, this is the approach that at the minimum you should use to solve the problem, okay? Are we clear on the first part? All right, so I'm gonna rerun Nana your output again, and just so that people see. So let's use, let's sort this. Let's use department 20 as an example, right? So 20, the total salary is 19,000, and that relative to the entire firm is 3%. So let's see if we figure out somebody who's department 20, an employee working on department 20, whether we get a salary of we should see 19,000 and around 3% in your output, okay? So let's sort this by, let's see department ID, okay? Right, so we see the 19,000 and we see the 3%. So your output is actually correct. What I'm highlighting is that because you lump them up, your final report, if you give me the report, I'm going, this is not what I asked you to do, right? But I understand what you're trying to do to sort of try to lump the solutions together. So that's the kick I'll have against your approach. But otherwise, I think it was pretty well done. So now let's analyze the output from the perspective of for each employee, right? So this guy makes 24,000, works in department 90. The total salary in that department is 58,000. So he's making about 8%. No, the salary of this department, which is 58,000 relative to the entire firm, is 8%. And this person's salary relative to the department, no, this is not right. This is not right. So let's look at this. I'm just going to highlight these records, right? So we have 3 people in this department 90, okay? I think. Let me just sort it out again. Yeah, there were 3 people in that department. So this is the record set that the data points we should focus on from a solution standpoint. One person makes 17,000. The other guy makes 24,000. And the other guy also makes 17,000. So the total salary is 58,000 as you show here. But if I'm interested in figuring out what the employee ID 102 makes relative to their department, then it will be something like this number divided by 17,000. And I'll take the reciprocal of it, and that should give us the ratio we want. Where is my reciprocal function? 1 over x. Where's 1 over x? In scientific mode, am I not? All right, 1 divided by. Oh, sorry, I'm not sharing that. Let me show you let me present the entire desktop at this stage. Can you guys see the calculator? Can you see the calculator now? Everything is gone. All right, let's do it again. All right, can you see now? Okay, so I'm highlighting this point about the result that there are 3 people in that department 90, right? So let me just clear this and then one person makes 17,000, the other guy makes 24,000, the other guy makes 17,000. Andy or Cyril, are you guys with us? I just want to make sure. I haven't heard from you guys in a while.
Yeah, I'm here. I'm here. Hello. I sent I typed in a response when you were asking on the calculator.
Oh, okay. So I'm highlighting that there are 3 people in department 90, and the first guy, okay, the IDs are 102, 100, 101, right? So one guy makes 17,000, the other guy makes 24,000, and then the other guy makes 17,000. So the total salary for the guys in that department 90 is 58,000. So you want to know, okay, how much does employee 102 makes relative to the money in that department? So you would say something like, okay, that person makes 17,000 and it's relative to 58,000, which is the total salary in that department. So that person makes about 29%. Okay, relative to the total amount of money in that department, employee 102 makes what? So your output should convey that. And that was what I was trying to show, now that I wasn't seeing that in our output. Fine, I'll get to that. I was trying to make sure that we understand that the comparison is that you say, for the total amount of that money in that department, how much is that person making relative to the average, right? So if let's say we say that, okay, the average salary in this department is 19,333, right? Which is what you got, right? Oracle is giving it to us, but it's simply a matter of saying 17,000 plus, sorry, where's my plus sign? 24,000 plus 17,000, that's 50,000. And the average would just be 3 people in that department. So the average is 19,333. So the question is, the guy who's making 17,000 relative to the entire department, right? And that's where that's why I commented this section that this is the approach that you should be using, which is you say you find the average salary within that department, and then you compare that. So you would say, for the person who's making 17,000, they're actually making 19,000 relative to this. They're making 19,000. Where's that? Backspace 0.33. So this guy makes about their salary is about 13% less relative, or 12% less relative to the entire department, the average in that department. Is this clear? So that's why you have 0.88 here, Nana, and you have 1.24, because this guy, the guy who makes 24,000, he's making 24% more above in that department. Oh, I'm not what's supposed to be made, but what it is the average in that department.
So, if I don't correct it, you want us to show the percentage less or more, or
you know, I mean, I see that you did quite a bit of things there, right? So, as you know, I'm going to just walk you guys through the solution, right? But you are there. I just want to make sure that I think you conflated quite a few things here, even though you got very close to what I expected. I want to show you guys, like, okay, the first approach is to do it. You know, the first question is this one. The second question is what you did here, which was you would say, right? I would say go ahead and say select department ID, right? And then just do average salary. Type quickly, right? Group by department ID. But at a baseline level, in the second question, you're trying to figure out for each person how much they make, right, relative to the average in their department, as well as the average salary for the entire firm, right? This is the first piece that I mean, I would hope you guys will put together when you're solving this problem is you say, all right, I need a couple of pointers. I need two things. First, I need the average salary per department. So let me see if I can capture that first. So that's all right. Let me see if this query gives it to me. When I run it out, it's going to give me the average salary. Right now, again, I'm talking about problem number 2, right? And problem number 2 says, let's find for each employee how much they make relative to the average in their department, as well as to the average within the firm. So the first thing we want to find out is let's find the average salary per department. And Andy would say, well, then let me go find the, I also need the average salary for a firm. Okay. So I would do something like this. I'd say, all right, let me just do, I just build them in separate pieces, right? So I'll just say, well, I don't care here. I don't care about the department. I just care about the average salary. So average, so firm salary, okay? And there's no need to group by. This is ANSI SQL, SQL standard way we solve it, right? So these are the two critical pieces of data points you need to get. Try to solve the problem. So knowing this, you say, all right, because I now need to find for every employee and compare it to the whatever, right? I'm going to do this. Select R on HR.employees. Let's join. That's my temporary data. My temporary data cannot have the semicolon in there, right? So T on E dot department ID equal to ET dot department ID. By this point, I should have E dot star, and I should also have and just get E dot employee ID. I also want to get DT dot star. Okay, just give me everything that you have in DT dot star. So let me analyze this output to see if it makes sense. Okay, so right now I'm getting the employee ID, the department ID, and the average department. Now, notice that I have not included the average salary for the entire firm because we cannot really join, right, with the average. So that is something that you will use later on when you get to that point. But our first objective here is, guess what? Let's find for every employee how much they're making relative to the average in the department. So let me go grab E.salary. Okay. Now, what do I have? Sorry, I've typed something wrong. E.salary. And I missed my semicolon. That's why. All right. So I have the employee, their salary, their department, and the average salary in their department. So knowing this output, really the solution is I need to get the employee's salary, and then I need to divide by dt.average department salary. And this should give me, this ratio should give me M salary relative to average department salary. If this is not 30 characters, let's see, it should work. Let's see if this gives us something. All right, so now I have the employee ID, their salary, and their salary relative to the department. Now, obviously, we need to show the department they are part of in our output so that it's cleaner. So I'm going to just also expose the department ID in the output. Okay. And see how this looks. Now, for the folks who like to round things, let's just round this to 2 decimal places so that things look good. All right. The steps I'm going through right now, they are the same steps I encourage you to follow when you're solving these sort of problems. Is to say, all right, let me just do it step by step, step by step, step by step. Okay, now let's analyze this output to see if it makes sense, right? So I have this employee, they make 6,900, they're in department 100, and their salary relative to the average in the salary is 80%. That's what this actually means. It's like they're making 80% relative to the average in the department. So in order for this thing to look, my output to look neat, I need to also expose the department average salary so that I can get a better visual look of it, right? So at this stage, I'm exposing quite a bit of fields, so I'm going to move them into separate lines so that the query looks cleaner, right? Our focus here is line number 50 to line number 65. And when we run this query, we're going to get that. And then people who wants to keep rounding, it's okay, let's put some rounding in here, right? So this is, I can reuse this column name here, doesn't matter, alias, and it would say, this employee makes this, that. I'm not done. I want to order the output so that it looks a little better. This output is on the employee level. It probably makes sense to order by the employee. And I didn't tell you which approach to use. And oftentimes you get problem statements where they won't tell you, right? But they expect that as you are building it, you're going to figure out what is a better way to display the output. If there's a business analyst or a systems analyst who happens to write a document spelling out exactly what they want, you are lucky, okay? So I would want to order this result set by the first column, right, and see that. So you can order it in 2 ways, right? You can order by the first column, or you can order by the 4th column, right? So ordering by the employee ID, I will see it this way. And if I order by the department ID, that means the 3rd column, I would see it this way, okay? And oftentimes, a nice approach is to actually say, order by the department ID, and within the department ID, I want you to order by the employee ID in ascending order. Okay. Come on. Here we go. Okay. So looking at this output, right, is ordered by department ID. And the funny thing is, if you look at this department, there are 2 people there, right? There are 2 individuals. The average salary is 9,500. One of them is making 13,000. The other is making 6,000. So from a percentage standpoint, right, the first guy, employee ID 201, is making about 36 or 37% more compared to the average than the other guy. And the other guy is making obviously 63% relative to the average. So such a disparity is something that can alert HR to say something might, somebody can sue us for, not paying people equal pay for equal work, for example, right? So that's one business reason why you would do that, okay? Now we've at this stage, I've been able to answer the question of what every employee, find out the average salary within that department, and then compare that to what the employee is making. The final question was, okay, knowing that, now can I do this? The person's salary relative to the salary within the entire firm. So I would say E dot salary, which is the person's salary, compared to select average salary from HR employees. Now this is supposed to give us this expression. It's supposed to give us, I pick this person's salary and I'm going to run the average salary from the entire firm, right? And I want that ratio. So this guy, let me round it. Let's see, round up to 2 decimal places. And I'll give it an alias of emp salary relative to average firm salary, okay? What this effectively tells us is, where I typed something wrong, I'm missing a comma here, and let's see, there we go. All right, so it's very interesting, right? Because you look at this guy, the same employee 201, person makes 13,000. Compared to their department, they make the department average is 9,500, and they're making 37% more in your department. But when you compare the person's salary to the average within the firm, he's actually making twice the average salary for the entire firm, right? So this sort of analysis is interesting, right? Because you try to make some comparisons to make certain decisions. Now, so this person can come to HR and say, hey, I'm being paid 63% compared to the average of the salary in my department. Then the HR can come back, well, you're making about 92% of the average salary within the firm, so you don't have any problem, right? And they can go to court and they can argue these numbers, right? In terms of, okay, is the firm mandated to pay close to the average salary within the firm or the average salary within the department? And the legal guys can figure this stuff out. You as a developer, as a SQL developer, you'll be asked to run these sort of queries to come up with the numbers that the legal people can then sort themselves out with. Okay. So in effect, this is sort of one solution that would get you to the destination of the assignment. Okay. I'm gonna don't know about you. I need a quick 2-3 minute break. I'll still keep the screen shared if folks want to just take some time to reflect on it and think up some questions. After we resume, we would then move on to the agenda for today. All right, so a quick 2-minute break. All right, okay. Is it 2 minutes up? Let me see my timer. Okay, got 1 more minute. How's our recording going? Let's check on the recording. All right, recording is going fine. just share the SQL developer desktop. So screen sharing, stop, and now let me present just the SQL developer. Okay. Yeah, 15 seconds. All right, and we are back. My sound check. Is everybody back? All right. If you're back, can you say hello real quickly? Andy.
Hello.
Cyril. Emmanuel.
Hello. I'm back. I'm here.
Emmanuel.
Hello.
Nana.
Hello.
All right. So we got everybody back. Okay. So before I move on, does anybody have any question with the solution that I proposed here? Right. So just for documentation, there are no questions, just for documentation. We'll just put a comment here in the file. For each employee, yeah, salary relative to the average salary of the department, as well as to the average salary of the entire firm. Okay. The steps were, so we need to pseudo code. Now, I just threw out this word like pseudocode, right? So you go for some interviews and sometimes they don't want you to just put a code in. They actually want you to just give them a map of how the code will look like. It's not, so they don't expect it to be perfect. They don't expect it to execute. Through the thought process of saying, okay, here's what I need to do. Here's what I need to get. And then once I have this, I'm going to do that, right? So, the pseudocode is just a descriptive approach of how you will solve the problem using sort of the general syntax. So a pseudocode of this will be like, select employee ID, salary, the average. It won't be perfect like this one, which is working, but they want to see that you have a general gist of how the problem will be solved. The emphasis would be on making sure you understand what the final output would be, meaning that once you know the employee and their salary, you want to compare that salary to the average salary within that department, as well as their salary relative to the average within the entire firm. Okay. All right. So moving on to, I use this sort of, it wasn't really planned or deliberate, but in effect, guys, we've been able to kind of review what we learned the last session, right, in terms of the query workshop. So now I'm going to skip to my outline for today. We're going to now, I'm going to just touch on a couple of query concepts, and then we'll switch to learn about the Oracle Database Server architecture, okay? The last time we did this, right, I had mentioned something that from a performance standpoint, you can use something like with, right? And I told you that the width is a way to tell Oracle that I have this result that it's probably going to make my query inefficient, but I have no other way of doing it. So please just do it one time and store the information and then reuse it across. So how would we use like width? The problem occurs when, if you look at line 59, in our final output, it pulls the employee's salary, then it runs this query to get the average salary within that firm, the whole firm, and then divides it. So he's doing it every single time, right? So let's just run this one to see. So this, when I run this, it takes about 0.003 seconds. So in effect, 408 rows of data is doing this 0.003, right? It's doing it divided by 1,000. It's costing about 0.03 seconds just to do this piece of it, which is a total unnecessary cost, right? So you will see that in some, you go and you inherit a query, and somebody will solve this problem as with average, syntax wise would be with average salary of firm as this expression here, okay? And you'll do something like select from HR.employees, let's say E as the alias, E.employee ID. I mean, this is not a very good use of it, but this is just to highlight the point, which is you say E.salary, and you say E.salary divided by this construct here, B. Make this let's see. ABG cell. Hold on. ABG cell. Oh, sorry. This and that. Now this is going to end up doing a Cartesian join. So a better example to actually do would be to, let's say, department ID. Okay. So ABG department. So all right. So select and you join where E dot department and E is equal to average salary dot department ID. Okay, so what typo now? Department ID. There we go. All right, so I'm trying to highlight this particular approach where I keep making a typo with my I keep making a typo. Okay. Let me format this. Okay. You will see this construct sometimes, okay? In your what am I doing, guys? Group by it'll work this time. So you will see that this query that we've been working on, right? This assignment. In some cases, you go to somebody will solve it this way. They'll use a with construct. Now, the with construct is, I mentioned in the last session, is this a way for you to tell Oracle that I may be using this expression a lot, so just store the number so that I don't have to, keep doing it multiple times. So if you see this with construct, it's just a way to what they would say materialize your inner query results. So you would say something like, I want you, Oracle, to store this 10 rows of data into some area of the memory so that you don't have to keep running the same thing over and over again. Okay, it's one approach that you may see in a like somebody may give you a query to analyze, and you may see it. That's all that is doing there, right? So that's the with construct. Okay, I'm going to shift gears and quickly go over what we talked about. But I need to change what I'm sharing. So let me share my. I'll stop sharing this, and I'm going to share Google Chrome. Okay. All right. Let me go back to this one here. Okay. So a quick recap of what we did with partitioning, and then I'm going to then transition that to the database architecture review. So Cyril, this is more for your benefit, and then I'll answer Andy your previous question about the difference between partitioning and indexing. And then once that is done, we'll wrap up for today. Then I'll give the assignment. Okay. So in the last session, we talked about when you have an Oracle table, okay, and it has a lot of data, because these days everybody wants to do analytics, right? You need to find a way to structure or store your data in such a way that's very good. You may go for an interview and you hear the concept of a data warehouse, right? Data warehouse is effectively a large database infrastructure which has terabytes and terabytes of data, right? So because it has so much data, you really want to just put the most relevant data that people query often online, right? Which is the data that, like if you go to, for example, a bank, right? And it has all the customer records of withdrawals and deposits and all kinds of things, right? You as a customer, when you go to the ATM, what you really care about is your balance, right? You just, hey, do I have money to withdraw, right? So information about your balance is information that should be readily available. But they will have a history of all your balances in a huge table. So they will just make sure that the most recent balance information is what is available. So you have a table and it has all the, the date and the balance, But you just want to put only today's date and the balances for everybody in the ATM, right? Don't have so much data there when nobody's really going to care about how much balance they had even yesterday, right? They only care about how much balance they have today, right? So in database, when you create a table, you can partition it, which is you can break up the way the data is stored into sections so that you can easily make certain parts of it available. You can easily get rid of parts of the data that you don't care for, and by so doing, make your system much more efficient, right? So I used the example of the HR table, and I said, well, if we have this HR table and we have departments, right? Employee table, I'm wrong. It's actually the employees table in the HR schema, right? So it has the employee ID, the employee name, the first name, and the department. We can group how the data is stored by department, because oftentimes people may be coming and say, hey, can you give me all the people that work in the finance department, for example? You want that query to come back very quickly. Okay, so partitioning serves that purpose. So we highlighted that, and I said that's one of the features. It's an advanced feature of Oracle. In fact, it became available since 10G. Now, since it's sort of an ANSI SQL course, partitioning as a concept, I see that it's now more available in a lot of databases, the commercial databases. So SQL Server has it. Even PostgreSQL has it. Netezza, I'm sure has it, but I haven't used it there before, so I can't really vouch for it. But it's a standard. A lot of systems now that people, when you go and buy a laptop these days, you can get like 2 terabytes of data, right? Tableau has partitioning, okay, sure, but the partition that maybe Tableau has is a little different compared to what we are talking about, right? And you and I can get into the semantics of that later, Emmanuel. So from your database structure standpoint, when you create a table, you have the option to partition it by some column so that the data for elements that have the same, or rows that have the same column ID, will be grouped together on your hard drive. And I mean, I use the example that if you think about your laptop, right? You can have, I'm getting a lot of static. Emmanuel, can you? Okay, let me reduce. Let me mute you here. Hello. All right. So Emmanuel, I've muted your phone because I'm getting a lot of static or feedback from your end. I've muted your microphone, sorry. If you look at this, my local laptop here, I mean, you guys can see it. But if you go to your local laptop, you see that you have a C drive, an E drive, and all those things. It's just different ways where you can store your data, right? So some data may be stored on your E drive. Others will be stored on your S drive, whatever drive that you have, right? The bottom line is the data is being stored, and is being stored in such a way that you can get access to your data very quickly, okay? And then Andy said, oh, okay, so if I partition my data by department ID, right, the next example, can I sub-partition it by something else? And I said, sure. So within this, you can choose to sub-partition it again, right? So maybe after partitioning by department ID, you may want to sub-partition by maybe job title, right? So people who belong to the same job title in that department, you want to put them together in their own grouping. It's especially useful when you're dealing with data sets, which are like millions and millions of rows. If I would say that if your partition has less than 10,000 records, you're really not doing it right. So typically, you have to find a better way to divide the data so that you don't have just a lot of individual chunks of it, right? Say, oh, this employee table has, I mean, think about it, that if you were to partition this table by employee ID, then every single row will have its own partition because the table, the employee ID is sort of really unique for every row. So you don't want to do it that way. You need to find an element that is common across a lot of the rows, and then use that to group the data sets in your table, okay? And you would ask, and I say, okay, so what's the difference between this and an index, right? Without getting too technical about it, I mentioned that if you think of an index on a table, an index is simply a way for organizing the references to your data. So if you pick a book and you go to the index section of the book, and you say, well, I want to find all references to, let's say you pick a calculus book, okay, calculus book, and they pick it, and it's okay, can you show me all pages where there's a mention of derivative? Okay, then it will show you all the different pages that have it. But it will, it will tell you if the book's 1,000 pages, it will probably say on the following 100 pages, there's a reference to the word derivative, right? So the index is a way for you to quickly locate your data when you're running a select. Partitioning itself it helps with retrieval of data, but it was really invented more to address two main concerns. One is if I have to delete data from a huge table, it's a pain. And I said it's a pain because one of the key tenets or one of the key requirements of any system that calls itself as a database is the ability for you to recover data. So when you submit a delete statement to your database, it has to note, okay, that Cyril said, I want to delete this record. It makes a note of it. But if Cyril said, oh, I made a mistake and I need to go back to what it used to be like, the database should give you the ability to do it. How does it do that? By keeping multiple and multiple copies of a record's change, right? So the history of a record, it just keeps track of it in a separate area of memory. So if you ever have to delete, maybe think about it, like if you have, 100 million rows in a table, you have to delete 5 million of it. Now, the headache of keeping track of all the 5 million rows, deleting all of them and keeping them in an area that if you made a mistake, you can restore all the 5 million records back, is ridiculous. So when you submit a delete statement that says delete some records, and let's say it's 5 million out of 100 million records that is going to get deleted, that delete statement can take hours. However, if your data is partitioned and you know which, let's say I need to delete, or I have a request that says, I no longer have department 100 in my firm. Drop all the data referencing department 100. Instead of saying that delete from HR.employees where department ID is 100, if the table is partitioned, I'll just say alter table, drop partition P100, for example. And within a fraction of a second, all that data is gone. Okay. Most systems that you see, any database system that you will see, data comes in every morning or periodically, right? And data goes out, right? So you need to have a way to kind of get rid of data you don't need and to put in the new data because storage is expensive. Now, I know when you go and buy a laptop and, you get 2 terabytes and the laptop is $600, you think, oh, this is a good deal because 5 years ago, a 2 terabyte laptop was probably going to cost you 3 times that price. But when you talk about database systems, the storage of database systems is very, very expensive because we have to take backups and backups and backups. Because if database crashes, we need to be able to restore. So when you're building your database, you really have to be careful in terms of how you store your data. You have to think about it well and use concepts like partitioning to kind of organize your data better. Okay. As mentioned, partitioning is an advanced concept, and we will definitely get into it in probably either the next class after this if folks are interested. What I'll call the advanced SQL step 1, if that's such a title. But it's a very interesting concept to learn. And if you go for a job interview, somebody may ask you, oh, why would you use partitioning? Right? You just need to know 2 things, right? That is used to help get rid of data we don't care about, and it's used to help with performance, right? So those are the 2 takeaways I give to you. Now, to answer your question, Andy, or in terms of the difference between indexes and partitioning, as I mentioned, when you delete a record, there's a lot of overhead. One of the overheads is that when you submit a delete, it actually has to go into the corresponding indexes to delete the same record. And the index also has to have a record of what it used to be like before you deleted it. So it's a very expensive process. So in a lot of data warehouse systems, when I say data warehouse, huge database systems, right, you would use partitioning instead of indexes to organize your data. So most data warehouses, they don't actually have indexes. They just have data in huge table, in one, they'll create a table and will partition it, right? And then you create a smaller table that has the indexes for the most relevant data for your business process. I hope that part is clear to you, Andy. Okay. All right. So if nobody has any question about partitioning, I want to introduce in the last segment, I promised that we're going to talk about the Oracle database architecture. And so I'll put it this way. I'm sharing my thing, so you should be able to see this. Here's an example of an architectural diagram for an Oracle database server. Now, Oracle database now is in version 12c. 12c basically means 12 cloud. Oracle database server now runs in the cloud. And prior to that, it was 11g, right? I started working with Oracle from version 8. And so I did version 8, version 9, all the iterations of it. And then version 10g was one of the major infrastructural changes to the architecture of Oracle. And then 11g sort of follows suit to add more flavor. And 12c is also a major change. So Oracle looks like every 5 years makes us a major change to how the system is architected. I'm going to show you the 11g diagram because 12c is relatively new. And if you go for a job interview, it will be very important for you to understand how the 11g system is built, because within the cloud, you can think of each slice in the cloud as an 11g instance. I'll get into that detail right now. This picture you see here has a lot of components to it, right? I'll take a step back to highlight something, because in my intro, I said, think of a restaurant, okay, in terms of the Oracle database architecture. We have a restaurant, it's called the African Joint. You can come and get fufu, lapewa, kose, masa, all kinds of Ghanaian foods. And you come in there, it's a sit down and eat restaurant, right? So when you come in, you know, if you had a reservation, right, we would have reserved your seat for you, or we tell you, oh, just give us about 10 minutes, you get you seated. If you don't have a reservation and you come in and there's space, we'll let you go sit down, and what have you. Throughout this training, I used terms like architecture. I use and software, you know, is really an architectural thing. The concepts that have been used to build physical structures like bridges, how you know, office buildings, high-rise buildings, all those concepts are used in the design of software, right? So you have to think of them as it's not a new thing. Just when you're building software, the concept is not really new. Somebody's building a house, there has to be a plan for the house. Where is the toilet? Where are the bathrooms? Where are the, you know, whatever, the plumbing? How does it connect? Where does electricity flow through? What happens if you have too much surge of power? What happens when you have too much surge of water, the sewage, all these things that goes into a house, right? Somebody has to sit down and architect and put a plan together and see if this is going to put together. The same concepts are used to build databases or any software you can think about, right? So when you see a diagram like this and it looks all over the place, I want you to just take a step back and think about it, that somebody just put together a plan for some building, right? This is the plan for the Oracle database system, right? You just have to take your time and look through each one and look at each of these pieces as if like you were looking at the floor diagram of some home, right? And so, okay, here's a bathroom, here's a this, here's a that, right? There are lots of individual pieces in here that for an introductory or maybe intermediate SQL, you don't need to know. This is a DBA that has to understand every single box on this chart. A DBA has to know it. And in my experience, most DBAs know less than 30% of it. Okay. If they have a problem, they just open a ticket to Oracle and say, Oracle, this thing is not working. The Oracle guys will come and charge them $1,000 an hour to figure out what's going on. So going back to the restaurant example, we need to have a place in our restaurant that we will prepare the food. We need to have a place in our restaurant where come in, right, every day or whatever periodic schedule you have. We need to have a place where people will sit. We need to have a place where drinks will be kept. We need to have a place where people will walk around. How are they going to move around? We need to have a way to kind of keep track of the traffic flow to make sure that if some people have been seated for a very, very, very long time and others are waiting, we need to find a way to bump them from their seats, right? All these are things that will go into your mind when you're architecting or structuring a restaurant business, right? I'm using a restaurant as an example of a system, right, that you will design. Concepts when you think about Oracle database. So as I go through this diagram, I will try to highlight to you where the parallel is in terms of a restaurant. Okay, it may not be fully accurate, but the hope is that it will help you remember it, right? And you think sort of down the line will be useful. Now, it's a little all over the map there, so I don't know if you guys can see everything. So I'm going to sort of zoom in a bit for the presentation and try to focus in. Let me zoom out first. Come on. I'll highlight a few areas. Okay. So the first area you should care about is this one. It's called the System Global Area, the SGA. And like I said, Tableau stole these ideas from Oracle. The SGA, if anything, if you go for a job interview, you should know the SGA, GA, okay? And then you should know the database data and temporary files, the control files, the online redo logs, the archive logs, duplex archive. These are like a little bit more advanced than the flashback logs. Flashback is one of the most important nice features Oracle introduced since 10G. All right. So this section of the course, I'm talking specific to the Oracle database. Okay. I'm not talking about SQL Server. I'm not talking about any other database, even though the concepts or structure will be the same. Think of these things as very specific to the Oracle database. So what did I say? SGA, or the System Global Area, the PGA, or the Program Global Area, the database, temporary files, control files, online redo, archive, duplex, and flashback. When Oracle database was initially structured or built, the SGA, PGA, these cylinders which are sitting here were the fundamentals. So since version 8, they've always been there, except for, I would say, the duplex archive logs and the flashback logs. Those are relatively new things. If you go for a job interview, they don't expect you to know all of this, but they need to know that you understand the general architecture of it, right? At least for going for a developer role. Somebody can ask you, okay, can you just tell me some of the key components of the Oracle database server? Then you have to say SGA and PGA. Those two you should never forget. System Global Area and then Program Global Area. Then you have to remember these cylinders, you think of them as where your actual database tables reside. Okay, the actual space on your hard drive, which has been allocated to store the data, right? So these containers, as it were, is where your data actually resides. And there's a lot of communication between the System Global Area, right, and these containers of data. The System Global Area has, these components. It has the shared pool, it has a database buffer cache, the redo log buffer, the large pool, the Java pool, right? And these other components, right? Flashback buffer, sort, extend pool, stream. You don't need to know about these. What you need to know is the shared pool, the database buffer cache and then a redo. Some of these things like it's just a bit. The Java pool itself is because Oracle owns the Java software and it had used the Java component to build a lot of the pieces. It actually dedicated an area within it for Java. So Oracle systems actually work very well with Java programs because they own the Java software now, and they've built their database to interact very fast with Java systems or any Java program. Okay. Now the program global area is where, if let's say, we haven't done PLC call yet, which is the next, we're going to start next week. I mean, this coming Wednesday, is where if you write your programs to do specific things, this is the area you'll be using. Okay. When we are interacting with our database and we say insert a record, right? That instruction to insert a record will typically go through the SGA, and then the SGA will route the request to the right location within. So it would say, okay, somebody says insert this record, then it's going to say, okay, let me put it in this redo log area or whatever. Because guess what? If they insert it, they may roll it back, right? So if they want to redo it or undo, then I can use the log of their activity to restore the data. So effectively what it does is it's saying somebody adds a record, somebody deletes a record, somebody updates. Everyone is keeping sort of a copy. So anytime you want to recover, it figures out where was the last commit point. Commit, whenever you issue a commit in your database, is when the actual information gets routed from these caches straight down to the containers, meaning we are absolutely sure this information should be persisted. It should be sent down to the storage containers. So then it will come into this area, the database data and temporary files. Okay. Even if you commit it, Oracle allows you ways to actually restore data back to a previous commit point. Now, it's a very interesting, unique area that I don't want to get into, but it has to do with something called a flashback, which is Oracle allows you to restore your data up to a certain point in time. So you can write a query against the table and say, hey, select style from HR to the employees table, but use the data as of, right now it's 1:30, right? But use the data as of maybe 1:15 p.m. Then Oracle will give you the data because it knows how to quickly say, hey, this is how your data look like at 1:15 p.m. It knows it actually down to a microsecond level precision, okay? So some of these things, when you look at them, they will look very confusing and all that stuff. What I want you to understand is know the system global area, the program global area, the database data and temporary files, the control files, the online redo logs, and the archive logs, right? And the flashback logs. RMAN is basically every single database server you have has RMAN on it. RMAN is basically the database recovery manager utility. Is the one that takes backup of your data all the time. And so anytime your database is up, you need to have RMAN running. If RMAN is not running on your system and your database crashes, you have no way of recovering your data. So every database installation of Oracle needs to have this RMAN running. So when you go to an interview and they ask you, oh, which is the main component of the Oracle system responsible for backup and recovery, you say RMAN, right? Recovery Manager Utility. Okay. Now I'm going to ping this link to you guys on the meeting invite, and I'll see if you guys can access it. I mean, it's a publicly available information on Google. So if you click it, you can access it. Let me know, right? If you can't, then just do a Google search for Oracle Database Architecture. Sir, what do you mean by you thought it's running, man? That's actually a very good way to remember. It always has to run, because if it's not running, you have no way of to recover your data if your database server crashes. I mean, your database can crash. I mean, your laptop sometimes restarts, it crashes. You know, anything can happen. So Ironman is the one that's responsible to make sure that if anything happens, it can restore your database back to a state that you trust, right? It's almost like, I don't know how many of you have ever done a restore point recovery on your laptop or your computer ever, but back in the day, you know, Windows used to crash a lot. And if it crashed, you're like, oh shoot, they said go and restore it. And it's okay, when do you want to restore it to? Oh, as of 3 weeks ago, or as of 1 month ago, right? So you have to tell at what point in time you want to restore your data back, right? So RMAN is very important from a database standpoint. Is the main guy responsible to make sure that as data is being added and deleted and updated, it can help, it can keep all that information, it can back it all up, at least the committed data, and help you to restore the data back to the right point. So what actually happens, and you know, if you think about what the job of the RMAN is that you schedule it. You tell RMAN, hey, every 1 hour, take a backup. So think of your laptop, and let's say you have an external hard drive, and let's say you use some Python programming. You can write a very simple program in Python, which would say that every single hour, copy every single data I have on my C drive to my external hard drive. Okay. And so you know that anytime if your laptop was to crash, you can always restore your data back, or any data on your hard drive, you can restore it back to about an hour ago. Okay. RMAN's job is like that. It runs periodically. So if you're a DBA, you'll configure it and say, hey, this thing has to run every 5 minutes or every hour or every 24 hours. So it has different things that it runs. Okay. For that very reason. All right, let me do one more screen share for the video. Okay. At this stage, I'll take a pause and see if anybody has any questions, because I owe you guys 10 minutes. So you have 10 more minutes. So does anybody have any specific question regarding this confusing chart, admittedly, on the screen? Imano, do you see the parallels with this and Tableau? Okay. I'm getting a lot of feedback from Emmanuel's end here, but let me reduce. Okay. All right. So to recap, you can think of the SGA, right, as that part of the restaurant, right, that made most of the activities happening. People are sitting here and all that stuff. I particularly didn't mention a certain piece of this yet, and I was hoping somebody would pick it up. How does the database know that somebody wants to connect? Remember during the installation, I talked about the Oracle listener, right? So when we installed it on everybody's laptop, I showed you on the task manager how the listener was working, right? Let me just stop this and share my screen. Share screen. Task manager. Let me show you my Oracle. Everybody has this, right? So when you go to Oracle, it shows this one, right? My Oracle database service, the XE is running. You guys see my screen? Can you guys see it?
Yes.
All right, Mano, can you see the screen? Okay. So Oracle service and the TNS listener. The service is like the main restaurant, right? The listener is the people at the front of the, you show up there and they look at you. What do you want? Do you want to come and eat? All right. You have to wait. The listener's job is to it's like a gateway. People are coming in, it's trying to monitor traffic. All right. You want to connect? Database, can you take this request? Yes. All right. Then go in. Database, can you not take? Yeah, you cannot take because just too many people in the restaurant right now. So the job of the listener is this part of the system here, right? Database listener. It's always up and it has to be up. In fact, if you shut down the listener, right, it's actually a very good way. Like if you go to when maybe Facebook or any of these websites, they have a problem. What they tend to do is actually they will shut down the listener on their databases. Most databases have that. So that any new client requests will not be serviced while they figure out how to get rid of the guys who are in the restaurant. So it's like guys who are already connected to the database. It's like a restaurant where we just don't have enough people, and we don't have enough seats for people, and people are queuing up outside. So guess what? The reception area, they will just sort of close it, right? And then they will internally try to figure, okay, guys, please, they'll say, hey, please, we have a lot of, it's very busy today. It's a holiday. Everybody wants to come and eat. So if you please, if you're done, okay, the party's trying to wrap up so that other people can also enjoy the same service that you guys are appreciating here, right? They say something nice and then you leave, right? Then as soon as there are enough seats available, they open it up again. All right, come and sit down. Right? That's one way that a listener would work from the concept of a restaurant. So you come in and it says, all right, you want to do some work? All right. I've given you a seat. Now go and order and do whatever you want to do. So if I talk to SQL developer, right, and I go here, right now I have this George, right? If I click George, it took a few seconds, right? It connected to the listener and said, listener, George wants to come in and connect to Oracle XE. And remember, George is a user I created for myself, right? And it connected it. Now, some statistics, right? It pinged it, and it came back. All right, you can go in. And then it let me go in, right? The very attempt to connect to database always has to go through the listener, okay? It always has to go through the listener, okay? And once you're connected, when I start doing select star from HR.employees, I want to run this query. At this stage, it's not connected. It's connected to the database, but database has no idea what you're doing. You just connected. It's when I run this, I type this query and I highlight and I hit F9 or run this green button. That's when it's going to try to go and do something. Now, in this case, I ran this and it connected and said, hey, this table HR.employees does not exist. How did it figure out how to give me this response back? Because as soon as it connected, it said, you've connected as user George. All right, let me check the privileges of user George, right? So it's like kind of going to a restaurant and you have a gift card of $50 and that's all the money you have. And then you're trying to order something, they say, you are capped at $50, so forget about the expensive wines, okay? We cannot give that to you because we doubt you can pay when you're done. So, that's sort of what it does there. What it basically figured out was, as user George, I do not have access to the employees table. And then the way it figured it out was once I connected, right, it said, okay, you want to do a select. It goes into this area, and then it looks through a set of these caches and says, is this person authorized to access what they were trying to do? Once you pass that check, then it will check, oh, has anybody recently run a query against the employees table? Do I have that information already handy in my memory? Yes, then I'll give that to you. So if you install Oracle and you highlight this point, my Oracle is running, right? Let me show you the actual process. This is the Oracle RDBMS kernel executable. It just says Oracle Relational Database Management System. That's what RDBMS is. It's a general term, relational database management system. It's using up almost 300 megabytes of my RAM, no matter what, right? What is it using that 300 megabytes from? It's using it to that's mostly being used by this SGA. It loads up certain tables or certain objects people typically use. It will load that up into memory, right? So things about your access to certain tables is information that it always has to run. Anybody submits a query that says select to do something, insert something, delete something, the first thing it has to do is to verify that you have the authority or the privilege to do it. So that must mean information about how it verifies your privilege has to be very handily available in the system global area. That's an area of data that is commonly used across all processes or all actions that a user wants to take against the database. Okay, so the SG is a very, very important, in fact, the most critical piece of the database system, right? If you talk about database itself, is the SGA. That's where most of the action is happening from an interacting standpoint. But it cannot exist by itself without having storage for your data, because a database should store your data, right? So it coexists one in hand with these storage containers. Okay. I would take a pause here and give folks a few moments to digest while we wrap up the session. Does anybody have any question? Okay. Emmanuel, are you saying something?
Yeah, I was just going to. So when somebody.
Mano, can you mute your laptop when you're talking through the phone?
Yeah.
All right, go ahead.
So when somebody logs into the database, the first goes to the listener. So the listener used as like the gateway.
Yeah, the listener is a gateway. I mean, that's why I said Tableau has the same concept. Tableau has a gateway, right? Yeah. And that's the gateway that's responsible to figure out whether your request goes to a particular cluster of it. To say, yeah, it's the same concept here.
So after you determine, you go through the gateway, then it goes through the checkpoints to actually check if you have permission to do what you are asking for.
Well, so one of the basic things that it has to do is to say, someone you want to connect, the basic check has to do is, do you have access to connect to the database itself? Yeah. So that's like what you mean, like a checkpoint. So the listener is up listening for, that's the job, is listening for requests to connect to the database. And then as soon as a request comes in, it says, are you even authorized to connect to the database? Yes, you're authorized, go in, right? So when I expanded when I expand, I'm going to highlight this stock trading one, the second thing. When I expand it, the quick action it does is it checks that stock underscore trading underscore algo have the ability to connect to this database. It says yes, then it connects. If it did not, it would have come back with an error. You're not authorized to connect. You don't have the session is not. You don't have the ability to create a session to this database. That's the actual error it will give back to you. Okay.
Yeah. So I guess my confusion is that the listener takes the information. And then, okay, so all this will happen in a split of a second. So it takes the information and checks your credentials before it takes you into it gives you access.
Yeah, with that.
I think I answered my own question.
Yeah, that's all it does. Yeah, it's exactly like that. It's like any system, you need to authorize, right? So somebody wants to connect, you say, hey, are you authorized to even connect? Yes. All right, and if you're authorized, you can enter the main lobby, right? But now you want to go to this floor, you don't have access to this floor, okay? So that's effectively what it's doing.
Thank you.
Okay. All right. Nana, Andy, Cyril, does anybody have any question?
No, good.
All right, excellent. So I want to give you guys an assignment, okay? Let me mute it, Lando. Okay. All right, so I still feel that you guys need more query practice, which I'm sure all of you pretty much agree with, all right? So I'm going to give you another query assignment. I'm deliberately not giving you assignments on these partitioning and those sort of things. They are just mainly for you to understand, to have enough information to be able to get into do very well in a job interview, right? So that's why I do that. But these assignments, I want to focus in on the ability to write these queries and to do them right so that you, right, if you have to write a query in an interview, can do a very good job, okay? Or at least explain yourself very coherently. So I want to give you an assignment on query again. It's going to be the same HR table. And here's where I'm going to show you. All right. So far, the previous assignment, I said, find for each employee how much they make relative to the average of their department and the average relative to the firm, right? So whatever the employee is making, what is it relative to the firm? One of the issues we encountered was that in some cases, where's my employees table? One case we encountered was in some cases, the department ID may be null, okay? So I'm saying, okay, maybe I'm interested in saying, can you find for every employee their salary relative to their job ID? Right, the job ID is this column, okay? Once you've done that, maybe I should just, I'll type it out. I'll type it out and send it to you guys, but I just want to walk you through it first. So their salary relative to the average salary for people with the same job ID. Then I want to highlight this piece. There's another table that has for each job ID, the min salary and the max salary, okay? I needed to figure out what each employee makes relative to the minimum salary they're supposed to make for their job title, and then the maximum salary for their job title. So an example could be if somebody is an AD president and the minimum salary is 20,080 and the person is making 30,000, then roughly they're making about 1.5, right? And relative to the max salary, they're making about 0.75 of the max salary. Is that clear? All right, so I'll repeat. All right, so for each employee, find their salary relative to the average salary of employees with the same job title. That's the first part of it, okay? And the second part is for each employee, find their salary relative to the minimum salary of their job title, as well as their salary. If I can type this, their salary relative to the maximum salary of their job title. Okay, so that's the first one. And the second one is this guy. Okay. Just fix it. I'll send you, when I send the artifacts over the meeting, I'll repost the questions there, including the link to the video and the materials we discussed today. Okay. But just a clue, this requires you to kind of look at another table. So so far I've been working with just the employees table for most of the analysis. Now you have to kind of look at another table in addition to the employees table, okay, in order for you to get to the response. You get a lot of brownie points if you try to solve the problem the way I presented it here. And I will share this output with you guys as one of the artifacts for this session, okay? So. All right. It's Martin Luther King Day, so Monday is a holiday. So you guys try to enjoy time with family, but try to carve out some time to also do the homework and try to get it to me hopefully by midnight of session on Wednesday, which begins at 9 p.m. All right, guys?
All right. Okay.
Andy, I hope you found your phone.
I got a cheap one to use for now.
That sucks, man. Sorry about that.
So I'm not seeing the WhatsApps that you're sending. I mean, I'm not able to run that on this form, but I'll be checking my email.
Okay. Oh, so okay. All right. Then that's good to know. Then I'll try to duplicate most of the information that I send on the WhatsApp group through the email as well. Yeah. Okay.
Great. Yeah, all right. Thank you very much.
All right, guys. Enjoy. Thanks.
All right.
Bye.
Thank you. All right. Thanks.